Okay, this is the tutorial in MathC30 for the section 2.6, and that's solving equations with circular functions in them. Now you must use the unit circle in order to obtain possible answers. And there's one given to you in the back of your book on page 257. Note that on that it does not have the values of 10. Now I would recommend that you go and Google up unit circle on the internet and print one of these things off. Fairly easy to find on the internet, and I printed this one off, and you'll notice that it has all the values of cosine and sine, and then I went and I've added all the tan values around the edge as well, just so that it's easier for me to work with my tan in case I have a tan equation I have to solve. Now when you're working with tan, how you obtain this value here for tan is simply put, tangent is the same thing as saying sine divided by cosine. So all I would do to get this is, for this first example here, how I got root 3 there is I took root 3 over 2 divided by 1/2, which would be like multiplying by 2. So the 2's would cancel out and you get root 3. And that's how I've got all these tan values around my unit circle. So it's a good idea to have something like this handy when you're working in this section. And like I said, I would recommend just Googling one up instead of trying to make, well, you can make one if you want, but you can Google up a nice one like this. It's got degrees, plus it's got the radian measures, pi radian measures, and it's got all the values around for cosine and sine, and then I plugged in all my tangent ones around as well. So that's a reference circle that you'll be using. And I'm going to start here by looking at a couple of basic ones here first. Okay, so the first one I'm going to look at goes like this. It says solve each for one revolution. From 0 to 2 pi. Okay, so let's say my first one is I had root 2 plus 2 sine x equaling 0. Okay, I can't factor anything out of that one. So what I do there is I isolate sine x by itself so that I could then determine my answer. So isolating sine x by itself is the idea. So I'm going to take the root 2 and bring it over here. So this would be 2 sine x equals negative root 2. I'm subtracting root 2 from both sides. Then divide by root 2, or divide sine by 2 on both sides. So sine x equals negative root 2 over 2. So now we would take our unit circle and look for possible answers once around. So where on my unit circle do I see the values of negative sine value, which is the second value, okay, the second value in brackets, being at a value of what we solved there, and what was it again? Negative root 2 over 2. So negative root 2 over 2, nothing here in the second one, nothing, that was all positive, nothing right there. So at 5 pi over 4 radians, or 225 degrees, so 5 pi over 4 radians, and continuing around, now we're looking at the second value here. Right there as well, 315 degrees or 7 pi over 4 radians. So my answer is 5 pi over 4 and 7 pi over 4 radians for that solution. And that's my first example in solving an equation. Pretty simple one. All we have to do is isolate the sine by itself. So let's look at one that deals with a little bit of factoring. Let me flip over here. Make sure that's still in the view. Okay, so let's say I had instead this one. Let's say cos x tan x minus the root 3 cos x plus tan x minus the root 3 equaling 0. Okay, so in this one it looks a little bit complex, but it's a simple one as well. You have to take out common factors here and do a little bit of factoring. So I'm going to take out, you see I can take out a cos x here. So then I'm left with tan x minus root 3 in brackets plus tan x minus root 3. So 1 times that would be, we could write it out that way so that we can put it in a factored form. So then I have cos x plus 1 times tan x minus root 3 equaling 0. Therefore, we can say that cos x can equal negative 1, or tan x can equal, we bring it over there, positive root 3. So now we have to take our unit circle out and go around the unit circle and look for places where, look at your cosine one, that's the first symbol, and the tan one, okay, and see where those match up. Negative 1 for, let's do cosine first. Where is cosine negative 1? Well, cosine is the first one, right there, and that's it, at 180 degrees. Last time I used radian measure, so this time I'll just leave it in degrees. Now we can go looking at the tan. Where's tan positive root 3 in 1 revolution? Well, here's my tans. Positive root 3. Well, the first one that comes up is right there at 60 degrees. So 60 degrees. And as I go around, no, not a positive root 3. Oh, there's another one, 240 degrees, and that's it. So my possible answers, so x equals 60 for 1 revolution, 180, and 240. Okay, I'm going to do a couple more of these in my next tutorial. I don't think I got enough time to solve the next couple that I have here. So I'm going to do a couple more solutions here in the next tutorial.